Hey, this is just a basic primer on LED lighting for modeling or hobbying, model cars, trucks, whatever you happen to want to build. Just want to add a little bit of light to. I even have a 1/42nd scale lamppost here I got a light in. Anything you feel needs a little illumination, shall we say. So we have some basic LEDs here. These are 2mm LEDs. We have a variety of colors. They do come in more colors. This is just what I have on hand out of my handy dandy stash. We have a 3-volt coin battery. These are rated for 3 volts. I think the most basic LED is rated for 2.5 volts. If you put a 3 volt on a 2.5 volt rated LED, it will go pop and you'll get a little black center in your LED. So make sure the voltage matches the voltage of the LED. Here's a little red LED. Now it has 2 prongs. Those prongs indicate your lead and your ground. The longest on pretty much all LEDs. There are a few exceptions, but most LEDs, the longer one will be the lead. Actually, I can show an exception off right here. Here we have what's called a bipolar LED. That means that this thing has 2 colors. The longest prong is here, but that is in fact the ground. We have our 3-volt battery. Here is the positive, here is the negative. We put it in like this, see negative facing inward, and we get that light. And we do the other side, and there's a nice blue light. So that is an exception. But most of your basic store LEDs are going to be this way, where the long is your positive. There you go. Easy peasy, lemon squeezy. You can buy pre-wired LEDs, and I have an example of some actual SMDs, but they are pre-wired. Now, pre-wired are going to cost you $1 to $250. So they're just a little more expensive. Here's an example. This, when I bought it, had 300 LEDs in it, and it was $10 on Amazon. That is 30 cents an LED. So 30 cents versus $2. If you don't like to wire, if you don't like to solder, or if you don't have the equipment to do so, and you have some extra money, or you don't need 300 LEDs, then that route might be better for you. So basic bones LEDs, simple LEDs, simple 3-volt battery. Light one up. There's our red. So if you're doing, let's say we're doing a model car. I have some leftover parts from a 1/24th scale model truck I was working on, a semi-truck, actually, a Peterbilt. Oh no, it was a Freightliner. So I have some leftover transparencies. Here are your headlights right here. Headlights, easiest thing in the world to light up. One side is normally concave, the other is convex. We just take a nice white LED. If we're going for a modern car, you might want a cool white if you're going for an older model. But as you can see, we just put that behind there, and you get a really nice illumination. And the closer to the part you're going to put the LED, the brighter it's going to get. So you got your bright lights here, and if you move it back, yeah, you got your normal lights. So you can do things like that. And it's a matter of space too. Maybe LEDs will be too big and you need to move down to surface mounted diodes, which are SMDs. But as you can see, get some nice colors going, get some white going on the back of these red transparencies. You can see that looks nice, but maybe you want that to be more red. So we just use a red LED. I think that looks a little better. The camera is blowing out the LEDs. They do not look this bright. They don't have the white centers in person. Like, I can see through my monitor that that's got a really bright white center. Not in person. It's a nice red glow on this transparency. Or if you want more of an orange, then we can do something like this, and you get almost a red orange. That's a nice thing about having colored LEDs. If you don't want the color of the transparency to look like it is when it's lit, if you want it to look purple, just put a little blue behind the red, or we can go over here. You can see that'll give you a nice purple glow instead of the red. So when your vehicle is off, it'll look nice and red, but you turn it on, you get a little purple going. It's nice for custom builds when you're doing like street rods or anything that's supposed to be really fancy. And we have these too. Now, in some cases, you will not be able to fit LEDs in there, not have enough room. So then we're going to move to the SMDs. And there's a variety of sizes of SMDs. For my examples, I have a 603 and a 402. The higher the number, the larger the SMD. And as I said, these are pre-wired. So here is our 603. They're pre-wired, so they're kind of hard to get a hold of. And when you're dealing with things these size, it's actually, unless you happen to have very good eyes and are a very good solderer, it is almost better to get these in pre-wired, because there's no way I could even see the little contacts to wire that thing up. So I usually go with pre-wired. And being pre-wired, these are also resistored. You don't have to get them resistored. In fact, you could clip the resistor off, but for my project, I needed these resisted. These are 9 to 12 volts. That means they can take 9 to 12 volts. This is just 3 volts. So this isn't going to be super bright because it is resisting current currently. That was bad, but I said it. Let's see here. Let's get the negative. Pull that over here. And these are nice and small. So if you don't have any room, it's nice to have wires that are tiny. As opposed to like 5 mil or, well, I guess 0.5 mil wires or mil wires. As you can see, that lights up nice. Even on 3 volt, even though it's resisted, we got a nice brightness going on there. And as these are surface mounted diodes, they do have a direction. They are directional lights. Like the back side, if you flip this over to the back side, you're not going to get any illumination really out of that as opposed to the front side. So you're going to have to find a backing for them. That's why they're called SMDs, surface mounted diodes. They're mounted to a little tiny piece of plastic in there, or silicon, not sure which. But yeah, there is the 603, and they do make a variety of sizes of these. Let's see, here's a size comparison. There is a toothpick next to it. It's about the head of a toothpick, and that's fairly small. This is the kind of stuff that also, if you're doing, like, if you want to illuminate the interior lights, like the roof light of your car, you'd use something like this. If you want to illuminate the under the hood lamp from cars, we'd use like a 402, and this would be like a 1/16 scale car. I would put this on. It'd look out of scale in like a 1/24 or 1/25 scale, but on a 1/16, this is about the size of your under the hood lamp. So, yeah. And you get a lot of illumination. That's 3 volts on that tiny, tiny SMD. And again, this is just bright white. You can get different colors as well. So yeah, that's about the size of the under the hood light in, say, a 1/16 scale car. It might be even, this even might be a little too big, and they do make, I think, one size smaller than this. So, just a few applications for these. I think on my truck build, when I did my Freightliner, for the headlights and the bumper mounted fog lights and the tail lights, I used these 603s to illuminate those, and you get plenty of light. It is very bright. And they were resisted, and all those lights are running off a 3 volt battery. When you have even less room, or you have a lot of things you want to illuminate at once, the LED route is pretty much impossible, and the SMD route might not be economical. In that case, what we want to do is we want to use something called fiber optic. Now, fiber optic is just plastic, basically just plastic wire. And this is 0.5 millimeter right here. So if I was illuminating something that had a series of lights instead of by, like, let's say there's 20 lights in a row I need to illuminate. Let's say I got a tractor trailer. I got the trailer. I want to illuminate the lights on the edge of the bottom of that trailer. But I don't want to buy 20 SMDs, right? One side's 20 SMDs, the other side is another 20. That's 40 SMDs, and that is a total of 80 individual wires you'll have to be wrangling. In that case, it is much better to have to wrangle 40 fiber optics than all of those wires are. Let's say you're actually be 80 wires, because 80 wires total, because it's 2 per and there's 40 lights. I can math. So let's say what you're illuminating are red lights. So we'll do this up with a red LED. And the nice thing about this is you can take your LED and put as many fiber optics as you can fit into it. This is a 2 mil. If I was doing something with, like as I said, it was like 40 lights, I would probably use a 5 mil, which is what I showed you earlier. This is a 5 millimeter bulb. You can also get 10 millimeters. Maybe you want to use a 10 millimeter bulb. All depends on the size, the amount of lights, and the size of fiber optic you have. So we'll just put this fiber optic up to this light, and as you can see, that illuminates a nice pinpoint of light. Now let's see if we can do this. Let's see how much I can do with this one hand. All right, we got that illuminated. It's kind of slippery. Let's see if the battery will stay in there. Please stay in there, battery. Let's bring over our red transparency and put it up against one of these. If you can see that, it is illuminating through that little side light there. Illuminate through these side lights here. You can illuminate these marker lights. And if you don't want a pinprick of light, sometimes you don't, you can just mount the fiber optic back a little bit from it. Get a little illumination. Or if you want it to look like there's a light bulb in there, you just put it right up against the transparency, whatever transparency you're using. And if I was illuminating these red ones, I would use a red LED instead of a white one. The same thing with the these amber ones here. We'll just do that as an example. If you want to, some of these lights are what are they called? Some of them are turn lights, but some of these are actually mirror lights. Those little lights you see on the mirrors of some of the old semis. That's what these are. So we've got our amber going on right there, the little pinprick of light. And then I would put that behind these guys. Right there. Kind of difficult to see, but it is illuminating that amber transparency there. And it's not just illuminating in the pinprick, it's actually illuminating around the sides too. These little guys over here too, it'll illuminate those. Just kind of an example. And sometimes you have to, sometimes you want to actually drill a little bit of a hole in the back side, just a tiny bit, like a pin vise or something, a tiny bit of a hole, if you want the pinprick of light, and just kind of, you'll have a slot to basically mount your fiber optic in. It makes it a lot easier. Just a little drip of glue. Do not use super glue on fiber optic. It will become brittle and crack, and it will fog it up. Use something like, you could even use good old Elmer's school glue for that kind of thing. Or use some canopy glue. I use canopy glue quite often. This is a very nice glue. And the nice thing about canopy glue and Elmer's glue, if you don't like where it is, you can just use some water. They're water soluble. So you can just use a little water and pop it on out. In some cases where you have multiple colors and you don't want to add another bulb, if you wanted to put it in, like let's say red, if you had a bunch of lights, let's use my neck for my Enterprise I'm building right now. So these are all white LEDs I have mounted in here, with the exception of the two up front. But let's say I want this window right here in red. Well, instead of trying to pull a fiber optic from this red LED up here, which the photons do illuminate red, instead of trying to pull a fiber optic all the way over to here and try to illuminate this, which again, wouldn't illuminate it as good as if I just put some red transparency behind the window and use that to illuminate it. So in that kind of instance, I would use a transparency, a gel. This is basically acetate. It's red acetate. You can get it in several different colors on Amazon. But yeah, just a simple red acetate. Another thing about fiber optics, they are flexible, but do not try to bend them at 90 degrees. They could bend about like that. That is the furthest I would pull it, maybe a little bit more. If you try to bend this at 90 degrees, this will fragment the plastic inside here. And when the light hits where that fragmented, it is not going to give you any illumination out the front. Little or no illumination out the front. I've done this several times, trust me. If you want to bend an LED more than this, you can use a lighter. Let's see if I have a lighter on me. I do have a lighter on me. But you have to be very careful. This stuff, let's see how close. There we go, right there. You can see it melted. So there we got our bend. And, whoo, hot. That should still transmit light just fine. But do not try to bend it. See, you can see the, there it is. There's the pinpricker light. As you can see, it's still illuminating. There's another technique called blooming. If you need a little dome light, like tiny little dome lights on something, you just bloom the end of this. So you have to get in here. Be very careful with this. There we go. And that actually domed the tip of the fiber optic. So you're going to get a nice little dome. And this actually helps if you want to pull your fiber optic through the hole you're trying to illuminate instead of trying to push it this way. If you just want to pull it through, I've done this several times. I'm trying to think of it. Oh yeah, I was creating I'll show that off right now. I created this this is an officer's lounge for the Enterprise, and I wanted to add a couple of lanterns in here, but I just didn't want them sticking up willy-nilly, so I bloomed. So when I mount these on here, there's little holes on either side of these red chairs. What I will do is I'm gonna mount my amber LED somewhere in here, and then I'm gonna take some fiber optic. I'm gonna pull it through there. I'm gonna bloom the tip and pull it all the way through, so I have an anchor for my fiber optic. Sometimes you'll want an anchor, and this is one of those instances. So stuff like that. So I think that's what I'm going to cover for right now. If you guys have any questions, feel free to ask. I didn't get into anything advanced. I didn't get into our resistors or even wiring, but I can do another video if you guys want me to. This is just kind of a test video just to see what you guys think. So I'm going to stop rambling and end it now. I hope this helps someone. And until my next video, you guys take care.